All right, 7.1, graphing growth and decay functions. So all exponential graphs will have a horizontal, that means this way, asymptote, which is a horizontal line that the graph approaches. But doesn't cross. Okay, so do something like this. It'll come down and never hit it. It's kind of like a force field. It just doesn't want to hit it. So an exponential growth function is in its form where f of x equals b to the x power, where b is greater than 1. So it has to be a big number bigger than 1. Usually it's going to be a base number of like 2 or 3. Most often you'll see, but it's any number bigger than 1. Okay, so when we do this, we're going to go to our calculator. And we're going to put in 2 to the power of x. That's our exponent. Need to check something real quick here. Sorry. And we hit graph. Now you see what it's doing is it's coming down and not hitting the axis, because literally this is plus 0. That's where our asymptote is, and you're going to see me get in the habit of putting an asymptote where the force field is, the fence. Okay. Now I'm going to go to the calculator and get a few key points. Okay. Such as 0, 1, 1, 2. 2, 4, and 3, 8. Now, I'm not going to fill in the table. I'm not going to expect you to fill in the table all these smaller numbers as they get closer to decimals. That's fine. You don't have to fill all this in. No big deal. As long as you get 0, 1, 2, 4, and 3, 8. And then you get the idea that this is going to basically come down like this and just ride out along this fence, never crossing, never touching. And that's it, pretty much, for the graph. Now, the domain, remember, domain is left and right. So this is going to keep going left, and it's going to keep going right forever. So this is always negative to positive infinity. That will not change for these exponential graphs like this. All right? The range, though, how high is it going? Up towards infinity. But the low point is going to be 0. And it's never going to hit it, so we're going to use the parentheses. So it never touches 0. The y-intercept is right here, 0, 1. And the asymptote is always going to be a horizontal line, so y equals, and that's going to be 0. This number right here is your asymptote. As we start having transformations, you'll see that number show up. Right? Next one, 10 to the x. Again, this is just going to change to that, like so. Same general shape, a little steeper though, you'll notice. So when we go to our table, zero, 1, and 110. And then you can see how it climbs so fast. Again, plus 0. So our thing is going to be right here, like so. So we have 0, 1, 110. So it's just going to come down like this and just, again, ride out that fence. You just do your best. It doesn't have to be perfect. Just don't cross that line. Okay? Like so. Don't worry about these points. Don't worry about that. That's enough. That's all you need. Domain not going to change again. Negative to positive infinity. The range on this one, same thing. It's going towards positive infinity, up forever, and never hits 0. The y-intercept, again, right here, 0, 1. And that asymptote is going to be y equals 0 again. Now decay is where b is less than 1. So it's a fraction less than 1. And you can't just say fraction, because you could have 3 halves, which is 1.5. So it's got to be a fraction less than 1. Okay? I think you got the idea with the calculator, so I'm not going to pull that up anymore. Well, I guess for this one I will. Now remember, with calculator, with something like this, you could just do 0.5, okay? But you could also do 1 divided by 2, in parentheses, raised to the power of x, like so. And then on the next one, you would just change a 2 to a 10, okay? So for this one, you're going to have -3, 8, -2, 4, -1, 2, 0, 1 again. Then you start getting the little tiny decimals. That's good enough. All right. Again, the asymptote, since there is no extra number out there, is going to be the x-axis. So -3, 8 is up here, -2, 4 is here, -1, 2 is here, 0, 1. So again, you're just going to sketch it coming down, hitting those points. And again, as you get close to this little wall, electric fence here, whatever, force field, you're just going to write it out like so. Right? Again, the domain's not changing, negative to positive infinity. The range, now this time, notice, again, it's still going up towards positive infinity, and it's still coming down, not hitting 0. Even though it looks a little different, it's still the same thing. It's going up forever and going down until it almost hits 0 and then stops. All right? The y-intercept, again, right here, 0, 1. And the asymptote is going to again be y equals 0. Remember, it's y equals, not x equals. All right? Now, with this one, for the next one, 1/10, we could change that 2 to a 10th, all right? But remember, you can also hit alpha y equals if you ever want to put in a fraction, like so. Just another way to do it. And then you would raise that to the power of x. So again, here we're going to have 0, 1, -1, 10, and then, these are going to be huge numbers. These are going to be tiny decimals. So that's really all you need. Here's 0, 1, -1, 10 right here. Again, that asymptote is going to be right here because, again, this is plus 0, this is plus 0, all right? So you're really going to have the steep curve right here, write it out just like that. Nothing's changing here, negative to positive infinity forever, not hitting 0, going up forever. Y-intercept again is 0, 1, and the asymptote is y equals 0. So no real change there. Okay, so questions to think about and you need to know. What makes a function exponential? That's when your exponent is x. Okay, what's the difference between growth and decay? Well, growth, the base is greater than 1, and decay, the base is less than 1. What's the difference between a growth and decay graph? Growth looks like this, and decay looks like this. Will the domain be the same for every exponential? That is, yes. Will the range be? No. Because as that asymptote changes, it will change. Describe the end behavior for growth functions. Okay. Well, as x approaches infinity, that means as x goes left, f of x is infinity. And, I'm sorry, this is right. And as x goes left, f of x is 0. And for decay, as x approaches infinity, positive infinity, f of x is 0. And as x approaches negative infinity, f of x is infinity. So for this one, you could say, as it goes left, it's flat, and as it goes right, it goes tall. And over here, as left, it switches left tall and right flat. Okay. That's why we have that general shape like this. And why we have this general shape like this. Okay, so now we have transformations from f of x equals b to the x, and f of x equals a b to the x, plus or minus a number plus k. And that number here is going to be h. And technically it's always x minus h, the format of the formula, but it will be plus or minus depending. Remember, inside lies in that situation. Alright, so A, the letter out in front here, stretches vertically if A is greater than 1, or compresses if A is less than 1, and reflects the graph over the x-axis if A is negative. A lot of times people call that a flip. H, the inside lies, shifts the graph left and right. Remember, inside lies. And K, up and down. And it's as we see it. Plus is up, minus is down. K is the horizontal asymptote. Therefore, the range depends on K. We'll see how that reflects down here. So, identify each as growth or decay, then describe the transformation. So, this 2 means growth. Let's just do this first. So, the tricky thing here on this one is the 3 and the 1/2. This is actually the number you look at because that's what's attached to the exponent. So, this is 1/2, which means it's decay. Over here, again, you look at what's attached to the exponent. That's a 2, so that's growth. And then here again, it's a 2. Sorry about that. So that's growth. Okay. What I usually say is, think about it this way. Think about a little kid holding a balloon. All right. This is your exponent. The little kid is the base. Now, maybe if the kid's a little too small, there might be an adult with them, a parent, and that's your A. That's the number that changes your graph. Now back to transformations. This one means down 4. On this one, remember, inside lies, so plus actually means left 4. And this 3 means stretched. Remember, the 3 does not mean growth. 3 is the A in front. That's the parent with the little kid. Here we have 1/2, so that's compressed. Inside lies, right 1, and up 5. Over here in this last one, the negative means a flip, and the -6 means down 6. Okay, this one we put in our calculator, we're going to get 0, 12, 1, 8, 2, 6, 3, 5. And that's all I'm going to show you. This plus 4, remember, is the asymptote. So there's going to be a line right here at y equals 4. So then when we go to put these on, 0, 12 is up here, 1, 8, 2, 6, 3, 5. So when we draw it, it's going to come down here and again ride on out the line, like so. The base is 1/2, that makes it decay. So the domain does not change, negative to positive infinity. The range still going up to infinity, but remember this time it's changing because that number, that plus 4, goes right here, which is also going to go down here for the asymptote. So the 4 is here, here, and right up here. It's a very important number to remember. And the y-intercept was at 0, 12 we had. And then the transformations were up 4 and right 3. Remember, inside lies. Okay, so this one has a base of 2, which means it's growth. This is my asymptote. So I'm going to put that in right away at -3. That's not the best straight line, but you get the gist. And some points here. All right, so this one's got 1, -11. Slightly off the chart, but easy. It helps us see what we're doing. 0, -7, -1, -5, -2, -4, And that's about it. So 1, -11 right here, 0, -7, which is our intercept, -1, -5, which is right here, -2, -4, which is right here. And again, it's going to come up, and then it's never going to quite hit -3, like so. So the domain does not change. Again, the range this time is going towards -infinity, which always goes on the left side. And then it's coming up and not hitting -3. And we leave that in parentheses again because it's not going to hit it. The y-intercept was 0, -7. The asymptote is that y equals -3. And the transformations are down 3, left 1, that's that inside lies. It's flipped because it's negative, and it's stretched because that number a is bigger than 1. So there's a lot going on. Down 3, left 1, stretched, and flipped. That's where that all comes from. All right, 2 more. All right, this one we have decay, 1/3. This is our asymptote again at -2. I'll try to make it a little straighter this time. Now, as I've told you before, you can easily just put in, when you're graphing this, 1/3 of the x, just to get your parent function, then put this in the second one, just to see the transformations a little more obviously. Okay, so we have 1, 7, 2, 1, 3, -1. That's about where we're going to go. 1, 7, right here, 2, 1, and 3, -1, and that gives us our shape right there. It's going to come down and just ride out that fence. That's all we need. Domain does not change. The range is going towards positive infinity and coming down and not hitting -2, which is our asymptote. And the y-intercept is at 0, 25, which I did not put on the chart, but it's way high up there. And again, our transformations, the -2 means down 2. The -2 up top inside lies means right 2. The 1/3 does not compress it, that is the base. The 3 does stretch it. Okay, and that's all you need for that one. Okay, this is a tricky one. This 3 tells us this growth, which generally we think of going like this. But this is going to flip it. So you'll see how it looks a little bit different. All right, so we have 2, 3. We have 3, 1. We have 4, -5, and then we're off the chart. Okay, and our 0, I'll just throw it in there, is going to be at about 3.9. So again, this is our asymptote. So we're going to put it up here at +4. Again, that 0 is going to come in at 3.9. It's going to be almost impossible to see. 3, 1 is right here. 4, -5 is down here. And 2, 3 is right here. So it's going to go this way this time because there's that flip going on. There's that 3.9 for 0. Hard to see. And here we go. The domain does not change. The range this time is going towards -infinity and not hitting +4. The y-intercept is at 0, 3.9. The asymptote is at y equals 4. And the transformations, the +4 means up 4. The +3 at up top, inside lies, so that's left 3. And the -3, the negative flips it, and the 3 stretches it. And that's it.